In everyday life, we usually think of space and time as separate things. Space tells us where something is. Time tells us when something happens. But Einstein's relativity changed this picture. Space and time are not completely separate. They are linked together into one larger framework called spacetime. This idea helps explain time dilation, length contraction, the speed of light, and even gravity. In this video, we will explore what spacetime means, why it matters, and how it changed our understanding of the universe. Here is what this video will explain. First, we will look at the everyday view of space and time. Then, we will see how Einstein changed that picture. Next, we will explain what spacetime means. We will also look at events in spacetime, where something happens at a particular place and time. Then, we will connect spacetime to time dilation, length contraction, the speed of light, and gravity. The main idea is simple: we do not live in space alone. We live in spacetime. In ordinary life, space and time seem easy to separate. Space is measured using distances and positions. We can say that one object is 5 meters away, or that a person is standing at a particular place. Time is measured using clocks and calendars. We can say that an event happened yesterday, today, or at 3 o'clock. This everyday picture works very well at low speeds and weak gravity. But when objects move close to the speed of light, or when gravity becomes very strong, the simple separation between space and time begins to fail. Relativity shows that space and time must be understood together. Einstein gave physics a new picture of reality. He showed that the speed of light is the same for all observers in uniform motion. This one idea has deep consequences. If the speed of light stays constant, then different observers may not agree on measurements of time and length. A moving clock can be measured to run slower. A moving object can be measured to be shorter along the direction of motion. These effects are not separate tricks. They are signs that space and time are connected. Einstein's new picture links space, time, motion, and light into one framework. Spacetime means that space and time form one combined framework. In everyday language, we describe where something happens using 3 directions: left or right, forward or backward, up or down. These are the 3 dimensions of space. But an event also needs a time. It is not enough to say where something happened. We also need to say when it happened. So spacetime combines 3 dimensions of space with 1 dimension of time. Spacetime is a 4-dimensional way of describing reality. In relativity, an event is something that happens at a specific place and a specific time. For example, imagine a flash of light. To describe that flash completely, we must say where it happened and when it happened. The place gives its position in space. The time gives its position along the time direction. Together, these describe a point in spacetime. This is important because different observers may describe the same event using different space and time measurements. But the event itself remains part of the same spacetime reality. An event is where and when something happens. Spacetime helps us understand why motion changes measurements of time and length. In special relativity, observers moving relative to each other do not always divide spacetime into space and time in the same way. That is why a moving clock can be measured to run slower. This is time dilation. It is also why a moving object can be measured to be shorter along the direction of motion. This is length contraction. These effects may seem strange if we think of space and time as separate. But they make more sense when we see them as different views of one spacetime structure. Motion changes how observers measure space and time. The speed of light is central to spacetime. In vacuum, light travels at the same speed for all observers in uniform motion. This constant speed shapes how space and time fit together. Physicists often use a light cone to show what events can be connected by light or signals. Events inside the light cone can be connected by cause and effect. Events outside the light cone cannot be reached without traveling faster than light. So the speed of light is not only the speed of a beam of light. It is part of the geometry of spacetime itself. Light speed helps define what can influence what in the universe. Special relativity describes space and time for observers moving at constant velocity. It explains time dilation, length contraction, and the speed of light limit. But Einstein went further. He developed general relativity, which includes gravity. In special relativity, spacetime can be treated as flat. In general relativity, spacetime can be curved. This curvature is connected to mass and energy. Planets, stars, and galaxies shape spacetime, and objects move through that curved spacetime. General relativity turns gravity into the geometry of spacetime. In Newton's picture, gravity is a force pulling objects together. That picture works very well in many everyday situations. But general relativity gives a deeper explanation. Mass and energy curve spacetime. Objects then move through this curved spacetime. For example, Earth orbits the Sun because the Sun curves the spacetime around it. Earth follows a path through that curved spacetime. This does not mean gravity is unreal. It means gravity is understood in a deeper way. Mass tells spacetime how to curve, and spacetime tells objects how to move. Let us now gather the key idea. Space and time are not completely separate parts of reality. They are linked together as spacetime. This framework helps explain why moving clocks run slow. It helps explain why moving lengths contract. It helps explain why the speed of light is such a deep limit. And in general relativity, it helps explain gravity as curved spacetime. The key takeaway is simple: we live in spacetime. Thank you for learning with Prep for Uni Online. If you want to understand relativity more deeply, continue with our lessons on special relativity, time dilation, length contraction, E equals mc squared, light speed, and general relativity. Prep for Uni Online provides free university preparation resources for students exploring physics, engineering, science, technology, mathematics, humanities, business, health, and the arts. Our goal is to help students build strong foundations before university study. Visit Prep for Uni Online and continue your learning journey.